Today we are going to see correlation and regression. That's the third chapter of business mathematics and statistics. Okay. So in this chapter we are going to see these contents. What is the correlation? What is the bilateral data? Then types of correlation. What is scatter diagram? Merits and demerits of scatter diagram. Then covariance and its properties. And what is Carl Pearson's coefficient of correlation? So we are going to see these 7 terms today. First one, what do you mean by correlation and bilateral data? So correlation, it means the linear relation between the two variables is called as correlation. It means when we see the frequency chapter, at the time we have seen there are two variables, suppose x and y. They have a specific relation between these two variables. So the linear equation between these two variables, that is linear relationship between these two variables, is called as a correlation. Okay. So what do you mean then bilateral data? So for bilateral data, it in correlation if interrelated variables are in correlation, interrelated variables are called as correlated variables. It means if there are x and y, there are two variables we have selected for the finding out the correlation. These variables are called as correlated variables. For example, marks and intelligent quotient of students, Q students and marks. There is a relation between these two contents, right? Two variables. There, it means mostly those students has a high IQ, they have a high mass, or vice versa. So there is a particular relationship between these two variables. That's why there is a relationship between these two variables. It is called as a correlation if it is formed in a linear format. Again, there is an example rainfalls and agricultural products. If there is a proper rainfall during the particular 3 to 4 months of rainy season, then the agricultural products will be very flourished and it will be sufficient for the whole year. So rainfall is directly connected with the agricultural product. Then demand and supply of product. If there is a high demand and it also has a effect on the supply also. When you want a price of the particular product, you have to define the price of particular product. That time you have to check out the demand and supply ratios, right? Or what is the demand for the particular purpose in the market, and from that you can define the price of the product. Then height and weight of person. Okay, so same person, if there is a heighted person, for example, there is a more technique, right, where we calculate the weight, height, and your proper body mass technique. It is called as body mass technique. So it count the height and weight of the person, and you will define how much proper weight should be there as per your height and age of the person. So it is also one of the relationship between these two variables. So these are examples of correlated variables which can be used for the calculation of correlation. And what is bilateral data? So bilateral data is in order to determine correlation, we require data regarding two concerned variables. These data are called as bivariate data. So bivariate data, it means when we find out two variables and there is a data collected on the basis of these two variables or two qualities. This data is called as a bivariate data. Now, types of correlation. So correlation has mainly 3 types. First one is positive correlation. So positive correlation, it means has the same chain, right? Correlation is defined within its relationship between two variables. So if there are two variables as a x and y, the relationship between these two variables define the types of correlation. So when this x and y, these two variables are behave in the same manner or opposite manner or in reverse manner, on that basis the types of correlations can be defined. So first one is positive correlation. So what do you mean by positive correlation? It is increasing value of one variable is associated with increase in value of other variables and vice versa. It means if there is a change in the value of height of a person, if we are considering height and weight of a person, that time increase in height also has a increase in weight. So they have a same flow or same relationship between these two variables. Then it is called as a positive correlation. For example, demand and price. When demand increases, price of the product also increase. Same marks can be higher if the IQ of student is higher. So these are the positive correlation. It means value of one variable in change in or increase in value of one variable is also increase in value of other variable, and vice versa. It means decrease in value of any variable, x variable suppose, and the same change, that is decrease in value of y variable, then it is called as a positive correlation. It means increase in both variables, or decrease in both variables. Second one is negative variation or negative correlation. Now in negative correlation, increase in value of one variable is accompanied by decrease in value of other variables. It means if there are these variables x and y, if there is a change in x is increasing, then y is automatically decreasing, or vice versa. X is decreasing, y is increasing. So it behave in upward direction. So increase in value of one variable is accompanied by decrease in value of other variables, and vice versa. It may decrease in value of one variable is accompanied by increase in value of other variable. So changes in the values of these two variables are in upward direction. So such correlation between these two variables is called to be negative. For example, supply and price of product. So when you see the law of supply or law of demand at the 11th or 12th, so there is this rule of supply that if there is a high supply of goods, then the price of the product automatically decrease, because there is a lot of quantity available in the market, so it impacts inversely on a price of product. So it's a negative correlation. It means when the supply increase, price decrease, or reverse, supply decrease, price increase. So it's a negative correlation between supply and price of product. And the last one is no relation. No correlation, it means sometimes change in one variable is not related to change in other variables. Then we can say that there is no correlation. For example, weight of student and marks in examination. There is no any relationship between these two variables. It doesn't mean that the high weighted person, or the student whose weight is higher has a higher score in exam. No, there is no relationship between these two variables. Or same height of the student. It means if there is a highest student, then you can give admission to this particular class only. So there is no relationship between these two variables. So such relationship, such variables are called as a there is no correlation between these two variables. Okay, so there are only three types of correlation. So in case of MCQ, they may ask you that the types of correlations, which are the types of correlation. So they may give you the options. There are three types of correlation: positive correlation, negative correlation, and the no correlation. Now, what is scatter diagram? So scatter diagram is the first step to visualize the correlation between two variables is scatter diagram. It means when you plot, it is diagram when we get when we plot the bivariate data on graph paper for two variables, suppose x and y, on the x-axis and y-axis. It means whatever data we have collected for the two variables under study, and from that bivariate data we plot the points on the graph, and with the help of this diagram we get the correlation between these two variables. So this diagram is called as a scatter diagram. With the help of scatter diagram, we get the idea about the existence of correlation and the type of correlation. So with the structure of diagram, we can define whether there is a positive relationship or not, or whether there is a negative relationship, or whether there is a correlation exists or not. It can be defined through the scatter diagram only. Its limitation is that it fails to give correct numerical value of correlation. Now it's a proper limitation of graph also. When we see the mean, median, right? There is a graph limitation for graph. If you are drafting a mode by graph, then it doesn't have a proper correct numerical value. So same here, there are a number of data available for the description or plotting the points on the graph. So in scatter diagram, its limitation that it fails to give correct numerical value of correlation if you didn't plot the data or plot the numbers properly on the graph. What is the scatter diagram? Types of scatter diagram. So scatter diagram is classified on the basis of structure. It means how it behave or what is the structure we see on a graph. For example, it's a x-axis, it's a y-axis, right? So when we point a bivariate data on the graph, the behavior of these points, whatever points you have get to the bivariate data, the behavior or the structure of these points is defined the classification of scatter diagram. So let's check out what are the types of types or classifications of scatter diagram. This one, it's called as a positive perfect correlation. Why it's a positive perfect correlation? Because you can see here the lines are in exactly same way, right? There isn't these plots are like these. They are in a straight line. It means they have a perfect positive correlation. It means percentage change in, suppose, x-axis is the same percentage increase in the axis of y. So it is called as a positive perfect correlation. It means whatever change in one variable, the same and exact change appear in the second variable also. That's why it is called as a positive perfect correlation. So for MCQ, they may give you this diagram, and they give you options that which type of scatter diagram it is. So it's a positive perfect correlation. Second one is, it is also positive correlation, but it is only positive correlation because it doesn't have a same change. It means change in x is also change in y, but it is not the same amount or exact change. That's why it is only a positive correlation. Another one is negative, perfect negative. In negative, they are opposite direction, right? There is change in x, it also has a change in y. Sorry. It is in a reverse direction. That's why it's a negative perfect correlation. And it is also negative. It's a negative relation. It means there is an increase in x-axis, but slight decrease there, and the change in the y-axis also increase. So decrease in x is result in increase in y, but it is not an exact amount or exact the same decrease percentage or same decrease ratio. That's why it is only a negative correlation. But if there is a same exact change, that is decrease in x is same amount of increase in y variable, or vice versa, increase in x is has a same amount of decrease in y, then it is called a negative perfect correlation because it got a single line on your diagram. But if there is a slight change in this variation, it means the decrease in x is not exactly the increase in y, but there is a upward direction. So that's why it is called as a negative correlation. The next one is now no correlation. Now here you can see here there isn't any has any link between these two, or any any data with x or y. They don't have any relation between these two variables. That's why it is called as a no correlation. Same here, you can see it's only x-axis, right? Change is only in a x-axis. There isn't change in a y-axis as per the data. So there isn't any correlation between x and y. So same here, again there is only change in y-axis. There isn't any change in x-axis. So there is no correlation. It means it's a fixed here. It's a fixed amount of y and change only in x-axis. Here it's a fixed amount of x and change in only y-axis. So there is no correlation. And the last one is, this is non-linear correlation. When there is a diagram like this or like this, okay, so it is not a linear format. Linear, it means exactly this one or this one. Okay, it's a curve diagram. So curve, it means it is a non-linear correlation. There is a correlation, but it is a non-linear correlation. So these are the types of classification of a scatter diagram. Now, what are the merits and demerits of scatter diagram? So scatter diagram has a merit that it's the simplest method of studying correlation. With the help of diagram, you can just define whether there is a correlation or not, and which type of correlations are there. So it is easy to understand because you easily find out the plotted dots or plots on the your graph. It is not influenced by extreme values. Right? Extreme values it doesn't affect by, because on graph you can measure maximum extreme values also with the help of scale. Scale you can define, and with the help of scale you can just plot the points on the graph and you can get the diagram. Then what are the demerits of scatter diagram? It does not give a numerical measure of correlation. So you cannot calculate correlation with the help of scatter diagram. So scatter diagram is only to find out whether there is a correlation or not and type of correlation. But for the purpose of correlation, you need a mathematical formula so that you can have a proper numerical measure of correlation. Then it's a subjective method. It means it's very crucial towards the subjects only, subjective matter only, and that's why it is not applied to qualitative data. So whatever data available, it is only in a quantity. If data cannot be converted into quantity, then you cannot apply this diagram, because you don't have a data in the form of number if there is no quantity, and if you don't have numbers, you cannot plot the graph, you cannot plot the uh, points on the graph, and that's why you don't get the scattered arrow. Now next part is covariance. So what do you mean by covariance? So covariance is the drawbacks of scatter diagram to measure a correlation. It can be overcome by covariance. Remember this line, because they may ask you what is covariance, or they may give you a statement and fill in the blanks that the drawbacks of scatter diagram as a measure of correlation can be overcome by dash dash. So it is overcome by covariance. So scatter diagrams जो लॉस आहे किंवा ड्रॉबॅक आहे, that is it cannot measure a numerical correlation, right? So it can be overcome through the help of covariance. So what do you mean covariance? So it is the joint mutual variation between two variables. So whatever variables you have find out, with the help of these two variables you will find mutual variation between these two variables, and jointly this mutual variation is called as a covariance. The covariance between x and y is denoted by covariance xy, and it is defined as covariance xy is equal to summation of x minus x bar into y minus y bar upon n, or it is also in a short format as the covariance xy is equal to summation of xy upon n minus x bar y bar. Just remember this formula, because they may ask you the sums. If they ask you in the examination, they will give you the values of summation of x, y, then summation of x and summation of y, and with the help of that you have to find out the covariance of x bar. X bar is equal to, what is the formula for x bar? X bar is mean the mean. So mean is always calculated as summation of x upon n, right? It's your x bar. Same here, y bar is equal to summation of y divided by n. So they make you the summation of x, summation of y, then summation of x, y, n. Then, and with the help of this, you have to find the covariance of x, y. So you can find out like this or like this. Now, what are the properties of covariance? So, covariance benefits ka, what are the its privileges? So, covariance xy is equal to covariance of yx also. म्हणजे same here, when you calculate the covariance of x y, that is x minus x bar into y minus y bar, right? This is the formula here. It's your formula, that covariance of x minus x by y minus y bar. When you go for the covariance of yx, it just shift here. So y shift here and x shift here. So there isn't any change in multiplication. That's why covariance of xy is the same as covariance of yx. Second property is covariance of x's is equal to variance of x. So variance of x is a multiplication. That is 2 times covariance. It is called as a variance of that particular variable. That's why covariance of xx. It means you are multiplying the same variable twicely. That's why it is called as a variance. So variance is a square of covariance. And in case of covariance of xx, it means it's a variance of x. Covariance of x and constant is always 0. Why 0? Because covariance formula is right here summation of xy. Any formula we can take summation of xy minus n minus x bar and y bar. It is your formula, right? When there is one element is constant, it means if it is a constant, that time automatically the value of this variable becomes 0 when we calculate with this formula or any formula of the covariance. That's why covariance of x and constant is always 0. The next is covariance may be negative, positive or 0. There may be a value of covariance. It means answer of covariance may be negative, it means minus or positive or 0. Whereas variance is always non-negative. So it is always positive. Variance is always positive in value. It is never negative. Now the last part is for today's lecture is the Karl Pearson's coefficient of correlation. Remember this that Karl Pearson's coefficient of correlation, it is also known as product movement correlation coefficient. So what is it is also denoted by the R, small r. Formula for this is R is equal to summation of x into x minus x bar into y minus y bar divided by under root summation of x minus x bar bracket square into summation of y minus y bar bracket square. Or to simplify, mostly we use this formula for the calculation, the second one, because it's easier to calculate instead of this one. So it's a easy formula to remember also. That is summation of xy minus n x bar y bar divided by under root summation of x square minus n x bar square into summation of y square minus n bar y square. There is also another formula for this using covariance and SD. It is mostly used in case of regression lines. The second part of this our chapter, that is regression. For regression lines, we use this covariance formula, Karl Pearson's formula. So R is equal to covariance xy divided by SDX upon SDY. So if they have given you the data of summation SDX and SDY and given the covariance or data available for covariance, then you will just go for the calculation of covariance of xy and divided by the SDX and SDY, you will get the R value, that is correlation coefficient. So what are the properties of correlation coefficient, that is R? Remember this R, small r is a Karl Pearson's formula and capital R is a Spearman's rank correlation. So there are two types of correlation. First is Karl Pearson, that is small r. It is also called as the product movement. It is first and most appropriate formula and mathematical equation which is mostly used in the calculation of correlation for the product or manufacturing area. And rank correlation, it is used for quantitative data. Qualitative data. Product movement, that is small r, is used for quantitative. It means where there is a values given for the particular data such as manufacturing products or height of the person, etc. For that purpose, R is a small r, that is Karl Pearson's product movement coefficient of correlation is more effective than rank correlation. And the rank correlation, it is used in the qualitative data where you cannot define the quality of a person. You just give a ranks to the particular person on the basis of their characteristics or their attributes, and on that basis you can use this rank correlation. So Spearman's rank correlation, it is denoted by capital R, and Karl Pearson's coefficient of correlation is denoted by small r. So what are the properties of this R? That is Karl Pearson's coefficient of correlation. First one is R always lies between -1 and 1. It is always remember when you find the answer of R, it is always within this. It is greater than -1 but less than 1. So it may be 0, it may be negative, or it may be positive. So what is the formula? So it means when it is -1, it means it is in a point format, 0 point or something, but it may be minus or 0 point something positive, or it may be 0 also. R is also 0, R may be 0 also. So on that basis, there are three interpretations of the correlation. First one, if R is greater than 0, then the correlation is positive. It is called as a positive correlation between two variables. If R is less than 0, then the correlation is called as a negative. There is negative correlation between the two variables. And if R is 0, then there is no correlation. So it is called as the interpretation of the correlation, that is R. Next one. Correlation coefficient does not change due to change of origin. It means if you have change, there is a change in each observation. If you add something in each observation data, or you subtract anything from each observation, then correlation coefficient remains the same. There isn't any change in correlation coefficient. Why? Because it calculates deviation from each value, and the same is divided by the number of observations. That's why there isn't any change reflected in the correlation coefficient if the same constant number is added or subtracted from each observation. Correlation remains numerically same under the change of scale. Change of scale, it means if we divide or multiply each observation by constant number, correlation remains the same numerically. It means the same amount, same number will be the correlation, whatever you have, whatever constant number you are multiplying or dividing the each observation. And the correlation coefficient between x and y is the same as that of between y and x. It means the correlation of xy is equal to correlation of yx. It's a multiplication, that's why same as the multiplication rule. Whether you multiply 3 into 4 or 4 into 3, you will get the same answer. Same here, correlation coefficient between x and y is the same as correlation coefficient between y and x. And the last one is correlation XX is always 1. It means correlation relationship between the same variable is 1. And if it is a correlation between x and minus x, it means there is a change in the variables of minus, same variables but of different sign, then correlation of x minus x is equal to minus 1. So now the second part, how to calculate the correlation coefficient. So there are two methods, one is direct method, second is derivative method. In direct method, first one we have to obtain the sum of x value, that is called as a summation of x, and hence we find out x bar. X bar, it means we just find out summation of x divided by n is equal to x bar. Then second step, obtain sum of y value, that is summation of y, and we can find out y bar. Third one, obtain sum of squares of x, that is summation of x square. Same, obtain sum of squares of y, that is summation of y square. And the next one is obtain sum of product of x and y, that is summation of x, y. And so you will use the formula, find r by applying the formula r is equal to summation of xy minus n into x bar y bar divided by under root summation of x square minus nx bar square into summation of y square minus ny bar square. So with this formula, you will get the correlation coefficient. Okay, it is direct method. Second one is indirect method. It is called a deviation method. When we use the deviation method, when there is a large values are given, observations are in a large amount or having a large impact, that time you will just select one constant number from the each observation, and that with the help of this deviation we can find out the correlation coefficient. So for deviation method, first we have to find out obtain deviation u as equal to x minus a. So from the x observation, that is observation of x column, we select one number as a constant, as a, assume mean, and we just calculate u as a x minus a. Same here, from the y series, we consider one number as a b, constant number as a b, and we find out deviation of each y value from b, and it is called as a b. Third one is obtain sum of u and v, that is summation of u and summation of v, and also obtain u bar and v bar. Step 4, obtain sum of squares of u and v, that is summation of u square and summation of v square. Next is multiplication, that is obtain sum of products of u and v, that is summation of uv. And the last one here, formula is saying you just have to replace x by x as a u and y as v. So formula remains the same, that is summation of uv minus n u bar v bar divided by under root summation of u square minus n u bar square into summation of v square minus n v bar square. So you just have to remember one formula of xy and it will be used in the same deviation or in a direct method. Okay. What are the merits and demerits? So it's a single value. Now it has a proper mathematical formula to calculate the coefficient of correlation. So with the help of Karl Pearson, we can determine a single value which summarizes the extent of linear relationship. And it is also indicates types of correlation. Types of correlation, it can be defined through the R, like it means what is the value of R? If R is less than 0, it means it is a negative variation, correlation between the variables. If R is greater than 0, then it's a positive correlation. If R is 0, there is no correlation. So you can define relationship, types of correlation with the help of value of R also. And the last one, it depends upon all observations. So it covers every observation, each and every observation under the study. That's why it depends on all observations of the data. What are the demerits? So it cannot be compared for qualitative data, such as honesty and intelligence, beauty and intelligence. These are the qualities of the person or qualities of any event. So for that purpose or for such type of data, we cannot use Karl Pearson's coefficient of correlation. And it is unduly affected by extreme values. So if there are extreme values, it means if there is a very distance between the two values in the data, then correlation coefficient may be affected because it depends on all observation. So it covers all observation and you have to find out the deviation. If there is a extreme value, then the deviation will be more, and more deviation result in a ultimately unrealistic result. And the last one, it measures only linear relationship. So it just consider the data in which the linear relationship can be formed. So it says limitation for the mathematical calculation of coefficient of correlation under Karl Pearson. It must be measured in a linear format only. If there is a non-linear relationship between the two variables, then this formula or this Karl Pearson's coefficient correlation or product movement coefficient of correlation cannot be used for the calculations. Okay, so thank you so much. So today we have covered this up to this topic. Tomorrow we are going to see the ranks, Spearman's rank correlation coefficient.